video is for the lab, The Basics, and the objective for the lab is to identify and label magnetic poles and observe how magnets interact with each other. The very first step of the lab asks you to wrap a single strip of masking tape around a magnet and hang it from a paper clip tied to a thread. As I mentioned in the pre-lab, you don't actually have to use a paper clip if the magnet that you're using, like one that I took off of the refrigerator, wouldn't, fit a paper clip. You could just tie the thread on, or you could tape the thread on. I decided to go to my shower curtain and I cut some magnets out of the bottom of the hem of my shower curtain just to see how they would act, and I liked my shower curtain magnets the best. So what I did was I taped the thread to the magnet, and as you can see, I don't even need my apparatus. I can do this just with my own body. Like in the days of old when navigators would tie a piece of magnetite to a string and see how the magnetite interacted with Earth's invisible magnetic field lines, I'm holding my magnet and observing which flat side is constantly pointing towards the north, which relative to where I am oriented, north is this direction. And I see this flat side is north. So here is the first of my taped and labeled magnets. There's a bunch of little magnets in the hem of my shower curtains, so I got another one. And once again, I let it orient itself in Earth's magnetic field lines. And all right, you're gonna come to rest any second. By the way, you should keep scissors and other magnets well away from the magnets you're using in the experiment so that it doesn't interact with your magnet and interfere with the lab. Okay, I think it's pretty much found its spot. The side without the tape is pointing geographic north. And as I turn myself, yep, I can verify that. And so I have labeled the taped side the south pole of my magnet. Now that I've got those two magnets and their poles identified, it says hold the magnets close together and summarize how the poles interact. So when I hold the north and the south poles up, they attract to each other. So the opposite poles attract. When I put north pole to north pole, I can feel that they are repelling, so I can scoot the two away, just pushing with the force of the magnets. And if I go south pole next to each other, once again, oops, you jumped up and flipped over, they repel each other. So like poles repel, opposite poles of the magnet attract. Now, I'm supposed to go around my home and figure out what common materials are attracted to the magnets and which ones aren't. So I have a roll of tape here that doesn't attract a magnet. I have a spool of thread. It's not attracting the magnet. I have a Sharpie marker. Sharpie marker, not attracting the magnet. What about a pair of scissors? Oh, my magnet is attracted to a pair of scissors. I've got a paper clip sitting here. Paper clip is attracted to the magnet. Pencil. I wonder if the end of the pencil. Interestingly, the end of the pencil, the metal there, is not attracted to the magnet. The lid of the jar is. And my faucet, the magnet does not stick to my faucet. So there's a list of items that are and are not attracted to a magnet. The last question asks, are all metals magnetic? Apparently not. The metal on the end of my pencil doesn't attract a magnet. And the metal of my faucet did not attract a magnet. So no, not all metals are magnetic. What do magnetic materials have in common? They are made of iron. If the metal is not iron, the magnet is not going to stick to it. And that's the end of our lab, The Basics.